So next we start looking at not just complex form, but what happens when we turn that into polar. So we're used to making the transition from rectangular form, which is x comma y, to our complex form, which is x plus yi. When we go from polar form to complex polar form, it gets a little bit more complicated. The polar form of a complex number is r times, and then in parentheses, cosine theta plus I sine theta. And then sometimes, or you're allowed to kind of crunch that down. Instead of writing out the full length r times cosine theta plus I sine times theta, or I times sine theta, we write this in what we call r kiss theta form, where you keep the most important piece of information. We have the r, the C stands for cosine, the I for sine, or for imaginary, and then the sine, and then we have the theta there. Either form is acceptable, and I'll do a little bit of both as we're doing problems here. The only thing you need to be careful is make sure you know what r kiss theta really stands for in case you need to convert it to something else. And so if you are starting with a complex number, z equals a plus bi, and you want to get the polar form looks like this, and you get the r value by taking the square root of a squared plus b squared from your complex number. You get the angle by looking at the tangent of theta equals b over a, and really what you'll end up doing is to find the actual theta, because that's what we would be after. It would be inverse tangent of b over a. Let's look at some examples. Okay, our first one, we're going to first graph or make a picture of negative 4 minus 4 root 3 I. And we're not going to do necessarily specific tick marks, but I do want to get a picture drawn. So I would be going to the left and then down. My distance to the left is the negative 4. And then this other side here is negative 4 root 3. Remember, I don't write the I here. The I just tells me that I'm going in the vertical direction, either up or down. So there's kind of two ways to tackle this problem. One, if you did not recognize, hey, this is a 30, 60, 90, which it is, by the way, but let's say you didn't notice that. It certainly is okay to say, well, I know from my notes or from the previous screen that r equals the square root of a plus bi, or whoops, write that again, a squared plus b squared. And so then here, that becomes the square root of negative 4 squared plus negative 4 root 3 squared, which ends up giving you the square root of 16 when you square the negative 4. And then when we square that, we get 16. If we square the square root of 3, we just get 3, so we end up with a 48 there, which would be the square root of 64, which means my r value should be 8. Now you also can get that 8 because this length, this leg, times the square root of 3 gives me my longer leg. So that would mean this is a 60-degree angle. This is a 30-degree angle. And I have a 90 here. And then I could say, well, the length of this shorter leg is 4. That means the hypotenuse, the length, must be 4 times 2, which is 8. So either way, you'd end up with that r value. You need to be a little bit careful if you're going to go the more generic way and say that theta equals the inverse tangent. When you're going to do inverse tangent, I would just worry about the lengths. Ignore the negatives for now. We'll take care of the negatives when we look at the quadrant. And we would end up that, and then that would be what you would type in, which gives you the 60 degrees. So you can get it doing the more formal, kind of long way. You also could just look at this and say, hey, wait a minute, this is a 30, 60, 90. You could figure out the r. To get the angle of rotation, no matter which way you do it, we need to remember that this is not the theta for polar. For polar form, we are always looking at how far would I rotate from 0, which is pointed to the right. And if I rotate it all the way around from here, I've actually got to go a full half circle plus another 60 degrees, and that's my actual theta for polar form. So 180, I had to do a full half circle plus 60 more, would mean I'm really looking at a rotation angle of 240. So then the two ways you could write your answer would be our r, which is 8, times the cosine of 240 plus I times the sine of 240. Or if you wanted to go the more abbreviated route, you would just write 8 kiss 240. And truly either of those is acceptable. The second one's definitely a little shorter to write. Some people actually like sticking with the first form because then they always remember what everything stands for. Let's look at one more. We'll start by graphing. Again, in the real direction, I'm going to the right. Then I'm going up because they're both positive. My distance along the bottom is the square root of 3. My distance up is just, well, it's really the number in front of I, which would be 1. And so again, this one happens to also be a 30, 60, 90. This time the 30 is down here, and the 60 is up here. Because 1 is less, square root of 3 is like 1.73 something. So 1 is the shorter one, shorter leg. 30 would be down here. And again, you could do this the longer way and do it with r equals the square root of a squared plus b squared. And then theta equals the inverse tangent of b over a. But we don't really need to do that. The shorter leg here is 1, so the hypotenuse would be 1 times 2, which is 2. So I'll have 2 times cosine, and this time we don't need to do anything to manipulate the angle. Because we're in quadrant 1, that 30 degrees from my triangle is my angle theta. Whoops. Started to write a theta there. So cosine 30 degrees plus I sine 30 degrees, and then I'm done.